This is another one of these total type of problems here. So they give us the rainwater is going into the drain pipe with that R of T, and then the rainwater is going out of the pipe at D of T. So this is the going in rate, this is the going out rate. Part A just says how many cubic feet of rainwater flow into the pipe. So I don't care what was already there. I don't care how much is going out. All I care is how much is flowing in, which is strictly the R of T. Your integral is an accumulator. So when you integrate between 0 and 8 of that R of T, math 9 that thing, it'll get you that answer right there. And then it tells us like when that's cubic feet per hour, that's the rate. When you integrate that, that's just going to give you cubic feet, how much rainwater, and it says how many cubic feet there. So we know that's our answer there. Letter B, it says, is the amount of water in the pipe increasing or decreasing at T equals 3? So since they give me two rates, here's what my mindset is. I'm going to take the 3, plug it into the R and D, and see which one is higher. If the going in amount is higher than the leaving amount, then the total amount of water is going to be increasing. But if the leaving amount is greater than the going in amount, then the total amount of water in the tank is going to be decreasing. So I plugged in 3 for the R, and for T into the R function, into the D function, and those are the two numbers that I got. Plug it into the calculator. And since D of 3 was higher than R of 3, that means the rate that the amount is leaving is greater than the rate that amount entering, which means if it's leaving quicker, that means the amount of water is going to be decreasing at that time. So you got mentioned decreasing since D is greater than R, something about that, we're good there. Now, letter C, really important, because they keep giving us these problems here. So we'll get good at those. But then if we're practicing this stuff with like letter C, that could be something kind of separates us with the rest of the nation here, all right? Now, it says, is the amount of water in the pipe a minimum? When it gives you a absolute max or min problem, it says minimum, maximum, greatest amount, least amount, and it gives you a closed interval, they're doing a 3.1 absolute extreme of problem. They're meaning for us to make an XY chart, and we're going to check the endpoints of the interval and the critical numbers. So we got to find our equation first and then figure out our critical numbers. So when it says the total amount of water, that's when we need to take into account everything. We got to take into account what was already there, how much water flowed into that drain pipe, how much water flowed out of that drain pipe. So I got an A equation here. It told us at T equals 0, there are 30 cubic feet of water in the pipe. So I got my initial amount. And then when you integrate the R, that gives you how much went in. So that's going to be positive. And then you got to subtract out the integral of D, because that gives you how much went out. So it's the going in amount, subtracting out the stuff that's going out, because then that's no longer in that drain pipe right there. And then just a little technicality, I always just put the T at the top and then switch those to like X's right there, because they don't have to be the same thing. My mindset is when I integrate this, I'll have X's, but then I'll take the T and plug it in, and then I got the T's that we want right there. So I don't think they'll be picky if you don't switch the letter there, but it's just real technical. We might as well just be safe on that. But there's our total amount of water equation. And if you want to minimize this, you got to check the endpoints and the critical numbers. Here's how you obtain the critical numbers. You take the first derivative, set it equal to 0. So the derivative of that is 0. The derivative of an integral is just that inside part. So that becomes that R of T minus D of T. That's like your fundamental theorem, second fundamental theorem of calculus there. We just plug in the T's there. But the derivative of the inside function is just, the derivative of an integral is just that inside function. And then so you got to do your R of T they gave us was that. You're going to subtract the D of T. So I distribute the negative through the parentheses. There's my R minus D right there. And to get the critical numbers, we got to set this equal to 0. So I showed you how to do that. This is a pretty crazy equation. You're not meant to do that. The calculator would do that for us. And it's been a little while since I showed that. I have that in the graphing calculator video. You could do that, but since we got a little time here, I'm just going to show you that real quick. So I graphed this function into my calculator already. So I'm going to scroll through there in case you messed yours up. Make sure it's in radian mode, but just check, make sure you got that typed in the same way. And then when it has trig in there, I hit zoom 7. So when I hit zoom 7, this is what popped up on my graph right there. A lot of times it'll look more chaotic than that. Notice that it tells us we're in between 0 and 8. So what I always do, then I hit my window button, I make my X min 0, I make the X max 8, and then I graph it. And your critical numbers is where your derivative is equal to 0, which is going to be right here. Also, notice we're trying to minimize this thing. And this is the derivative graph, and that goes from negative to positive, from below to above the x-axis. So there's a relative min right there. And then we're going to check it on our XY chart to see if it turns into an absolute min. Sometimes it'll be at those numbers, sometimes it'll be at the endpoints. It just depends. But they'll have on the rubric, if you're not checking all valid candidates, the endpoints put the critical numbers, then you're not going to receive full credit for that. Now, if the derivative did go from above to below, I wouldn't even worry about that one. That would have been a relative max. And if it's asking me to minimize it, I don't care about the relative max. But if it was asking me to maximize it, then I would take into account like, hey, if it goes from above to below, then I would worry about that one as well. So remember to find the zero. This one, we're going to trace it, put our cursor near there, and then we're going to hit second trace and go down to number 2 where it says 0. And then it says left bound question mark. You got to move it to the left of that x-intercept. On an increasing function, it'll be below the x-axis. I'm going to hit enter there. Right bound question mark, I got to move it to the other side of that x-axis. Make sure that y's change sign. And then once they do, you can hit enter again. Then for the guess, I just hit enter a third time. And then it gives us this 3.272 number. And that's what I got right there. All right, so it'll solve that for you. Please make sure you're practicing those on your own. And then that's my critical number, right? And then here's what we got to do now. So they tell us at 0, the amount of water is 30. So I already knew that one. But then I got to take the 8 and this 3.272, and I got to plug it into this equation right here to see what's that minimum amount of water in the tank. Now, since you already have this function graphed in the calculator, you realize this is r minus d. That is r minus d when I do that integral. So that is my y1, and I don't have to type all that in again. So let me just go out to my, so I hit second and then I hit quick, brought me out here. So I'm gonna go like 30 plus, and then let's get that here. So when I integrate between 0 and t, this time I'm gonna plug in the 8. So I'm gonna hit my math 9, and I'm gonna integrate it from 0 to 8. And then before I type all that in there, I already have that typed in. Make sure it is the same one, it's the right one, but my r minus d is that y1 right there, okay? And then so when I access that, remember, that's gonna be alpha trace. So if I hit alpha trace, there's my y1, that is my r minus d function right there. Just hit x in there and hit enter, and then see how it gives me that 48.544 number right there. And then the nice thing is I could just go up in there and then switch that 8 to the 3.272, hit enter again, and it gives me my 27.965 right there. So I think with all those little nice shortcuts and stuff with there, you really got to do a good job of studying this stuff and then just practice the nuts and bolts with that calculator. But it makes it nice that we could all handle doing that. That's real quick and then kind of neat the way that all works out for us. But you got to make sure you're able to get to that point, right? You got to use your brain and study the setups and get to that point, and then pay attention to what it asks for. This one's just asked for the time it reached the limit. So the minimum is your lowest Y value. Sometimes they will ask what is that minimum amount of water in the tank, and you would give me that answer, but they said what the time is, so you give me that time right there. All right, and then letter D, you're not really doing anything here. I mean, you kind of see my answer there. It might already make sense in your brain, but it says the pipe can only hold 50 cubic feet of water before overflowing, and it wants us to write an equation involving one or more integrals that gives the time W where the pipe will begin to overflow. So we don't need an inequality here, because just where it begins to overflow, that's when that thing is equal to 50. So I'm really just taking that total equation that we did in letter A, and I'm just kind of rewriting it there. There's the initial amount, and then since it says a time W instead of T, then I just made that a W right there, because you want to, what time is that? You know, this is 0 to 8, 0 to 3, whatever. You want to know what time it is. So just make that a W, and then you just could switch that to whatever letter you want. But then all I did was take that equation for letter A, set that equal to 50, and then adjust the letters a little bit right there. Warm apple pie with vanilla ice cream. Good combination.